Okay, so let us start. Today we are going to dwell into some of the tedious problem, like whatever we did yesterday, a basic little bit extended version of that today we are going to do. Like we completed all these kind of problems, isn't it? So let us suppose I have a ball, okay, and I just project it. These are my walls, okay. This is ground and this is my fixed wall. Okay, I project this particular ball with some kind of a velocity. Let's suppose that the velocity of the ball is given, that is 50 meter per second. The angle which it is making right now with the horizontal, let's suppose, okay, the angle it is making right now with the horizontal ground is exactly 53 degree right now. How much is that? 53. Question is, if at this time it is at a distance, if this ball is at a distance 60 meters away from the wall, okay, this ball is at distance how much? 60 meter away. And if it is going to collide, E is given to you. The value of E is exactly 1 by 2. Okay. The question is simple, that if it collides with the wall, then find after collision where it will hit on the ground. Find after collision where the ball hits on the ground. I have suddenly increased the level, but this will give you a great analogy if you think ahead. So try it. Hmm. Just you have 2 minutes. So this ball will go like this way, isn't it? And it will hit somewhere over here. Now, one thing is there, it has two velocity. One is 50 cos 53, isn't it? How much is that? Cos 53 is, remember that triangle? 35, 37, 53. So this is 3, 4 and 5. 53 is, cos 53 is 3 by 5, isn't it? So 5 tens are 50. So this is 30 meter per second. And similarly, I'll have one more velocity component that will be, yeah. So this will be 50 sine, yeah. So this is how much? 40 meter per second, isn't it? So I got my two of the velocities. So I'll directly write, okay, wait. So this is 40 meter per second, isn't it? Now the point is it hits the wall. Now when it is going to hit the wall, you see that here also it will have that same component of velocities also or not? One 30 meter per second towards this side and one 40 meter per second towards upside, isn't it? Now look over there. as you see, there is like on the vertical, 1 minute, sorry, I forgot. If you see, the vertical will be different. If we do not know what will be that. Okay. But one thing is that on the horizontal direction only, the velocity changes. Why? After collision. Because in vertical direction there is no such force. Are you able to get me or not? Whatever was going to be the vertical velocity, it is going to be present over there. Now we know that if this projectile was a simple projectile, then it would have been following this path, isn't it? है ना? तो अब ये पाथ यहां तक इसको फॉलो करता, लेकिन अभी कोलाइड हो जा रहा है तो ये पाथ तो फॉलो नहीं करेगा, है कि नहीं? तो क्वेश्चन आता है कि इसकी टाइम ऑफ फ्लाइट फिर क्या है? Which path it is going to follow? Are you able to get me or not? So what will happen? This ball after collision with increase or decrease in velocity, yeah, it will go somewhere over here, isn't it? Yes. Now you try to see. See, I'm projecting the ball from here. This is my actual range in time of flight t, isn't it? But yeah, but it is changing its direction and going in back direction. The point is simple. You need to understand one thing, that whatever time it is taking to come over here, the same time it will take to come over here also. The reason for that is very very simple, that in the vertical direction there is no extra force, and our time of flight is calculated with respect to displacement in y direction, with respect to the velocity in y direction, initial velocity in y direction. So there is no force which is going to change the initial velocity, external impulsive force. So there is no external impulsive force in y direction, and this is why our time of flight still remains same, which is 2u sine theta upon g, whether you go back or front, whether going back is extra range or not symmetrical or asymmetrical. See, this is not symmetrical. This gap over here is not symmetrical, but still the time of flight will be same, which is 2u sine theta upon g. 2u sine theta is 40, J is 10, 10, 10 cancel. 8 seconds is my total time of flight. Are you able to get me or not? So the question arises that if we want to find that where it has fallen, I want to find this distance. I want to find this particular distance, x. Okay. So it is simple, like the time it will take to go from here to this level, to this particular wall, whatever time it will spend from here to here, if I can subtract from total time of flight, then the subtracted part of the total time of flight can be utilized to travel distance x or not. Yes, so time to reach wall is simple. T, I have represented a distance is 60, and in that there is no acceleration. Velocity is given 50 cos 30, which is 30. So this is equal to how much? 2 seconds. So time left over is how much? It is a simple 6 seconds, isn't it? But as you see that the ball after collision does not move with same velocity, isn't it, along the horizontal direction. It has a velocity along horizontal final is totally different. This is my velocity along horizontal initially. Are you able to get me or not? So velocity, we know that as the ball is at rest, but E is given to us. So velocity along horizontal final is not nothing but E times velocity along horizontal initial. This is what we derived that day. isn't it? This is what we derived, that velocity is e times of original velocity. Huh? Okay. Is that clear? So this implies e times e is 1 by 2. Velocity along horizontal is 30. So this is 15 meter per second. Are you able to get me or not? So therefore, x, or distance along horizontal after collision, is simple. 15 is speed, leftover time, which is, sorry, 6 seconds. 15 into 6, which is 90 meters. So this x where we got as 90 meters. Are you able to get me or not? Is this clear? Chalo. Can we move to next question of this? Look over here. Now, let us do one more problem. One another kind of same kind of geometrical problem, but this time you are going to do. Okay, my ground is there, and then there is a vertical wall on that. Got it. The point is very simple. I throw a ball, but this time I have a consideration. What kind of consideration? Okay, let's suppose I project this ball with some. Let's suppose its velocity is given to us. Okay, the velocity is given to us as root under gh. What is the velocity? Root under means it falls down and it got projected with the velocity root under gh, which is making alpha angles with the horizontal. The consideration is what should be, let's suppose this ball was thrown at a distance d from this wall. Okay, then what should be the value of e such that such that it returns back to its same position. What should be the value of e such that it returns back to its same position? Now, see, if I project it, the ball will go like this way, isn't it? Then find the condition such that it returns back along the same trajectory. For what should be the value of e actually? This is my fixed wall. This is my ground. Yeah, this is that. Yeah, this g is acceleration due to gravity only. Just take it g only. Once again, I'll have two velocity components, isn't it? The first one will be root under GH cos alpha, isn't it? Second one will be root under GH sin alpha. Are you able to get me or not? Okay. And the point is, I got these two velocities. So time of flight is same. T is equal to 2u sin theta. You know that. Whatever happens, time of flight is not going to change. Okay, 1 minute. Let me just write it a little bit far. 2u sin theta upon g. So this is this time 2 root under gh sin alpha of. So what I'm going to get, I'll just write it in a simple form, root under 4h by g sin alpha. That's my time of flight, isn't it? Now, as the ball is projected, it will come with the same velocity over here, but it will be thrown back with a different velocity, isn't it? It will be thrown back with a different velocity. This is velocity along horizontal initial. This is velocity along horizontal final. So velocity along horizontal final is E times root under GH cos alpha. That's my velocity. So let's suppose this is C. This is T. Now time T is my, this is total time. I represent it as, so I'm writing a small t. The time taken by ball to reach this wall. Okay. Uh, in first case, okay. So this is d by root under gh, sorry, d by root under gh cos alpha. This is my time, isn't it? But when it returns back, t dash is my time to return back. That is also going, means if it is same distance they are traveling. So this is d, but with a different velocity, root e root gh cos alpha, isn't it? That's my time t dash. Now whatever happens, time t plus t dash is always going to be equal to total time of flight off, like originally we said. So this implies I can take d by root under gh cos alpha as common, and this brings us 1 by 1 plus e, isn't it? So I can write directly 1 plus e by e, isn't it? That is equal to root under 4h by g sin alpha. Is that clear? यही आएगा ना? ध्यान से देखो ये क्या क्या कैंसिल हो जाएगा, रूट अंडर जी कैंसिल हो जाएगा, isn't it? H it's same under the root. Okay, so it will be d tan alpha 1 plus e divided by e is equal to twice h. Is that clear? 1 minute. I'm going. Oh no, sorry. Sin alpha isn't top. 1 minute. So this I'm writing directly 3 1 plus e divided by e because इसको इधर send कर दो. That is twice of h sin alpha into cos alpha because that is in numerator. Okay. So I'll be left with d plus de is equal to uh, twice eh और 2 sin alpha into cos alpha h sin 2 अल्फा लिख सकता हूँ, है कि नहीं? तो ध्यान से देखो अपने को इक्वेशन मिल गया e का, that e is nothing, the required e is nothing but d divided by h into sin 2 alpha minus d. Is that clear or not? That's your required E, such that the body will do the collision and then it will return back to its same point. Are you able to get me? Is this clear? ठीक है, चलो तो आगे बढ़े। ठीक, अब समझना जरा, एक अच्छा क्वेश्चन दे रहा हूँ, काफी तगड़ा है। ओके। हम्म, इसकी कॉन्सेप्ट काफी तगड़ी है। ओके। इट्स नॉट, इट्स मोर देन ग्राउंड। स्लो हो गई। ओके, आई एम throwing a ball, but this time there is a little bit of analogy with that. Okay. I'm sorry. Let us just bring it over here. I'm throwing this ball from here. Okay. What has happened? 1 minute. We have. It is good. So I'm throwing a ball from here with some kind of velocity u. ठीक है? With some kind of velocity u. ठीक. अब ध्यान से समझना। Basically, it is thrown at some distance d, from some distance d from a fixed wall. This is my fixed wall. Okay. I throw it in such a way that it hits the wall at the topmost point, where at the trajectory of its topmost point. Okay. Got it or not? Okay. Now, question is, find the value of E. To find the value of E such that it returns to its original position. Original point. ठीक है? Yeah. Now, no, okay, do it. Let us do it first. Then we'll see. The point is, here, the ball is not directly returning to over there. If it is not drawn, if it is not saying that it is following the original trajectory, you have to see that how it is going. It is saying that both the walls, both this ground and the fixed wall, have the same coefficient of restitution E. Okay. This one is also having E and this one is also having E. Got it. So it's not returning. I'm just giving you a hint. It's not returning to its original point using the same path. How it is going is basically it's taking a second trajectory over here. It's falling because velocity gets reduced and it is too much far away. Then from here, it once again takes back the trajectory and it returns back over there. Okay. Yeah, it's not mentioned over there. Original point means this point. Yeah, what is the problem? Same point. But after successive collisions, it's returning. Okay. You have to even verify whether it can reach on third trajectory or not. Or third trajectory or is my third trajectory is even small. See, the point is very, very simple. It's returning to its original point. Okay. So previously it was saying that such that it returns back to its same position using the same trajectory. But here it is not saying that it is following the same trajectory. It is following three trajectories to return to that. What is? It was following the same trajectory to return back. Here it is not. Here it is following. Is it following same trajectory? Huh, so if it is not following the same trajectory, then the value of e should be different now. Because velocity is changing or not. Okay. Here, Arey Baba, here we tuned our velocity in such a way that it follows the same trajectory and then we calculated the value of e. Got it? Because there also we can do the same thing, but here the velocity will come to be different now because it is falling over here only. So you find that velocity first and then you find the value of e. We do not know. How come it is same? If it collides, then it is e times of vh initial now. So how come it will be same? See, the point is very very simple that what is the difference मतलब इन दोनों प्रॉब्लम में डिफरेंस क्या है बेटा भाई यहाँ पर ये ट्राजेक्टरी पीछे वाला ही फॉलो कर रहा है तो VH फाइनल जो आ रहा है वो इस तरह से ट्यून हो रहा है such that it can follow that same trajectory which is given in terms of E. Here also I'll get V final in terms of E, but it's not that same trajectory which it needs to follow. It's following the different trajectory. So the value of E is going to change because the trajectory has been changed. The velocity final has been changed. Arey Baba, so there it is changing but following the same trajectory. Now, what's the difference between these two questions? Can you just say me? Can't you see that there are two different questions over here with the with the different values of e? Because if I अरे एक बात बताओ अगर एक की वैल्यू e you have 1/2 एक एग्जांपल और एक की वैल्यू है e is equal to 1 और मैं एक ही बॉल को सेम वेलोसिटी के साथ ड्रॉप कर रहा हूँ दोनों में हाइट जब ये जंप मार के हाइट जाएगा वो अलग अलग होगा या सेम होगा तो फिर बात यहाँ पे क्लियर हो गया ना कि अलग ट्राजेक्ट्री है इसका मतलब क्या होगा इसकी ट्राजेक्ट्री यहाँ तक होगी इसकी ट्राजेक्ट्री यहाँ तक होगी तो दोनों की ट्राजेक्ट्री अलग अलग है या नहीं है अगर ई की वैल्यू चेंज हो जाती है तो ट्राजेक्ट्री अलग अलग हुआ या नहीं हुआ तो फिर so you have the different value of e for different trajectories here it was following the same trajectory so e was we were getting some value of e here I want the answer to be in this kind of way I want the value of e now got it no problem. So 4:30 to 5:30 or 5:45 I'll take the class, okay? 1 hour 15 minutes to 1 hour, okay? Is that fine? That is of oblique collision only, okay? Do this question. Okay, now let us see that still you have got the same concept. Same concept चारों तरफ apply हुआ. Just you think everywhere we are applying the same concept. We are working on time of flight. So here also, if this angle, oh, I didn't give angle. So let us consider this angle to be theta. So this is u cos theta, and this is u sin theta, isn't it? Hello. So here the horizontal velocity will be u cos theta, but this velocity along the back side will be e times u cos theta, isn't it? For this ball which is falling. Is that clear? So the point arises that what is this distance which this ball has fallen with in the first part? I call it as d dash. What I call it as d dash. Simple. So look over here. Let's suppose the total means if I just find d, d is nothing but range by 2, isn't it? If it is hitting the topmost point, range is what? Range is, if you see that in projectile motion, we write range as u into v. That is, no, means there is a trick to write that u into v by 2. Are you able to get me or not? So that is u square, okay, sine theta, cos theta, yeah, so divide by, means 1 minute. I think I can write this as UV by G. Sorry, I think I forgot. Yeah. So this is U square sin theta cos theta. So basically, I'm writing range as UV by G. Are you able to get me or not? Whenever you want to write range, it is just UV by G. Are you able to get me or not? Is that clear? So let's suppose if I want to find, let's suppose I want to write, what I'm doing is I'm just writing what I'm trying to say. I'm writing u cos theta as u. Just change it to u and u sin theta as v, such that or ux, or you can write, let us just write ux and this as uy. So this becomes ux into uy by g. Are you able to get me or not? That's my formula of range. Is this clear? So if we want to write the time of flight is nothing but twice of uy by z, isn't it? Is that clear? Hmm? Now, so look over there. See, when I'm moving d dash, d dash is the same part which is left for half of the time of flight because half of the time of flight is absorbed in the first trajectory or not. So first trajectory takes half of time of flight. So for d dash must be what is our velocity, which is eu cos theta after the collision with the wall into that half of the time flight, which is uy by g, isn't it? So this is nothing but e into ux uy by g. Are you able to get me or not? That is my d dash. Is that clear? Now, when the ball falls over here, when the ball falls over there, when it has came over here, you see that this time this velocity is known to us. Well, this velocity will now change. Previously, it was u sin theta. Now it will be e times of uy or r. And here it is going with eu cos theta. That is going to still remain same. That is u. Uh, That is going to be EUX. Are you able to get me now? Which was provided due to this collision. Are you able to get me? So, if I can find, I'll just write this as this distance as, yeah, D double dash. Sorry. This is D. This is D double dash. And this was D dash. Okay. So D double dash is going to be how much? Simple. E into UX into what? Time of flight, isn't it? So what time of flight I need to consider? Can you tell me? Uh-huh. What can be the time of flight? So for D dash, the time was T dash. For D double dash, the time is, let's suppose, T double dash. So T double dash is how much? E into UX. T double dash is vertical velocity we know. That is E into UY. So that is E, sorry, twice. टू होता है ना हाँ टू होगा ना टू यू साइन थीटा अपॉन जी हाँ तो ट्वाइस ई स्क्वायर समझ में आ रही है कॉन्सेप्ट सो दिस इज ट्वाइस ई स्क्वायर यू एक्स यू वाई बाई जी मतलब क्या किया हमने फर्स्ट ट्रांजैक्टरी हाफ टाइम में जा रहा है तो डी डैश जो जाएगा वो टी डैश में जाएगा विच इज हाफ ऑफ द ओरिजिनल टाइम है कि नहीं तो इसका तो टाइम ऑफ फ्लाइट हमें मालूम है तो डी डैश की वैल्यू मिल गई द हॉरिजॉन्टल वेलोसिटी इन इनटू टी हाफ वर्ड नॉट अब इसी हॉरिजॉन्टल स्पीड के साथ बॉल यहाँ पर कोलाइड करेगा वो सेम रहेगा क्योंकि हॉरिजॉन्टल में कोई फोर्स नहीं है बट वर्टिकली इट विल चेंज बिकॉज इम्पल्सिव फोर्स नॉर्मल इज वर्किंग इन vertical direction which is e into ey. So this d dash t double dash is simple twice euy by g into the velocity. I'll get the d double dash. Now simple thing is that d dash plus d double dash is exactly equal to how much distance d. So this implies g dash we have which is e into ux uy upon g plus d double dash is twice e square ux uy upon g and so that will be cancelled in over here and I'm going to be left out with twice e square plus e minus 1 is equal to 0 which is a quadratic equation. So to solve this simply I can write e is equal to minus of b which is minus 1 plus minus root under b square which is 1 square minus 4 a is 2 4 into 2 into minus 1 because c is minus 1 divided by twice a which is 2 into sorry b square minus minus b plus minus root under b square by 4ac minus twice a होता है ना 2 into 2 4 why not so e is equal to minus 1 that is 8 plus 1 9 which is plus 3 divided by 4 so this is how much negative is not possible so 2 by 4 which is 1 by 2 so e must be 1 by 2 such that the body must reach in minus b plus minus root under b square by 4ac minus divided by 2a 2a ही होता है ना ठीक है चलो तो it is 1 by 2 is that clear or not so simple it is just write the form of range and time and you'll get the answers are you able to get me or not okay okay so now this was all about the all the cases of different kinds of collision which we discussed Now we are going to follow the special kind of collision which we call it as oblique collision. Okay, where the line of impact is totally different from the line of motion, isn't it? This is our question, this is our condition. Okay, now here there are two to three important things which we need to understand. That's all, there are two balls. Okay, I'll just draw the line of motion. First of all, let's suppose and 1 minute, and this one is also moving. I'll draw this line. Okay, and this ball is also moving. Take the answer. The black line is line of motion. We'll check into that. Yeah, kind of here. Yellow line can be also told as line of motion. So these balls were moving. Let's suppose this one was moving with some velocity. Got it. And this one was also moving with some velocity. Got it or not? Yes. Now when they will collide, what will happen? Let's suppose they got collided over here. Okay. So they will collide in this fashion, isn't it? Are you able to get me? They'll collide in this fashion. So the normal, actually their normal acts along which line? Along this particular line, isn't it? A minute, sorry. Now, this is my direction of normal on both the balls. You got to see that their velocities was this side. Now, their velocities will change. Their velocities will be totally different. So we call this as line of impact. And we call this as line of motion, which provides us the unnecessary understanding that what can happen. Are you able to get me or not? Now, there is one more important thing to discuss over here, and this why I have drawn these two yellow lines. There is a reason for that. You see that there is a gap between these two yellow lines, isn't it? Between their centers. Are you able to get me? This gap between their center is called as B, which is called as impact parameter. Parameter. Why it is necessary to know? Because this is that line which is going to make us understand that what can happen if the collision is going to happen. Are you able to get me or not? If impact parameter is very small, the oblique collision will be very, very strong. If impact parameter is very big, then the oblique collision is going to be very, very less effective. Are you able to get me or not? So impact parameter is one of the biggest thing to understand in case of this particular oblique kind of collisions. Are you able to get me or not? So let us take an example of this. Means the conditions of their velocities. Their velocities, like one important point. Let's suppose if I get their velocities to be v1 or v2 whatsoever it is. So their velocities along the line of impact is going to be dependent upon coefficient of restitution, while the horizontal line, while the perpendicular line, that velocity is going to be same. So we'll get to know about this through examples, not through like we can't do using simple arguments. Okay, so we need some conclusions to understand this in a much more better sense. Okay. Okay, so now look over here. Let's suppose I'll draw two lines. Okay, so let's suppose there is one ball. Okay, I mean, Hmm. So this is one ball which is following that line. Another ball is not moving downwards of it, but actually at the center of it. Okay. So the velocity, oh, 1 minute. Velocity of this ball is given, which is v naught, and it has mass m, and radius of the ball is r. Okay, got it. This is ball A. It collides with ball B. Okay, which is of same mass and radius r, but its velocity is zero right now. बोल रहा है if हाँ if e is equal to 1 then find the speed of each ball after collision. Then find the speed of each ball after collision. Do it. बताओ. बताओ क्या हुआ. Okay, see this. When they will collide, this will be the diagram, isn't it? In this direction, they had the original velocity v naught. We will talk about that. This is going to be my line of impact. और कुछ तो बोलो हाँ है ना. That's going to be my line of impact, isn't it? Now, the point is simple that in this direction, they have velocity v naught, isn't it? So this velocity v naught will have two components now. One perpendicular to it, one parallel to it. Yeah, this is v naught. Let's suppose this angle is theta. Okay, let's suppose that angle is theta. I'm just going to draw this green line to much more understand. So this is v naught cos theta, and this will be v naught sin theta, isn't it? These are my normals, and this angle is also going to be theta then, isn't it? Sorry, wait. If this is 90 minus, okay, easier task is to take this as theta. That will give the right conclusion. No, so I'll just change it. Wait, because it. Uh, so let us keep this as angle theta. So this becomes V naught cos theta, and this becomes V naught sin theta, because it makes our calculation easy a little bit. Because if this angle is theta, this angle can be also given as theta. Are you able to get me or not? Now, you see that if we see the angle theta, then the gap between, try to see why I consider theta. See, the gap between two centers is how much? 2r, isn't it? This. Gap is how much? 2r. Well, this length is how much? R only. Yeah. And that angle is theta. So we can get the value of sine theta and cos theta in terms of r and r over there in a much more easy sense. Are you able to get me or not? Yeah. Now the point arises that how to write the equations, isn't it? Now if E is exactly equal to 1, what it is saying? E is exactly equal to 1. So for this, if this is ball B along the line of impact, along the line of impact, the velocity will be transferred to B, isn't it? We have to write the equation along the direction of B only, na? So along the line of impact, what will happen? The velocity will be transferred to B. Means what will happen is that if these are my two different balls, okay, after collision, you will see that this one is having the velocity V naught cos theta. Well, this one will have only this perpendicular velocity V naught sin theta. Is that clear or no? While the velocity along this direction after collision is exactly equal to how much? 0. So this is the scene of A and B after collision. Yeah, so V naught sin theta is how much? It is simple. V naught sin theta is perpendicular r by 2r. So V naught by 2. And cos theta is base by hypotenuse. So base is 4r minus r. That is root 3r, isn't it? Root 3r. So this is how much? Root 3 by 2 V naught. Are you able to get me or not? Yes. So you got the angle theta also. That angle theta is almost equal to, I think, 30 degree. If I can see, या फिर नहीं कुछ अलग होगा छोड़ो इसके ऊपर ध्यान नहीं देंगे. I think if I write theta sin theta, हाँ 30 degree only. So at what angles they go basically is sin theta is equal to half. That implies theta is equal to 30 degrees. So after collision they are moving. Yeah. So after collision they are moving 30 degree with respect to each other. Is that clear or not? Got it. So I'll give you one question based upon these, and then we'll solve in the next class, which will be of 1 hour and 15 minutes. Okay. Let me just complete this question, then I'll discuss something. Okay. I'll discuss something. Okay. So this is one of the mass which is having mass twice in and moving with velocity how much? V naught. ये काम करते हैं थोड़ा अच्छे से लिखते हैं तब मजा आएगा. सो इसकी जो मास है वो है ट्वाइस एम और रेडियस है आर. ठीक. And it is moving with velocity v naught. This velocity is given v naught. This is mass m and radius r. Let me just draw those two lines, 2 to 3 lines. Okay. Okay, their centers are not coinciding right now. Okay, they're not moving in such a way. Okay, 1 minute. I need to put it. It's not that much down. It's not even that much up. Okay, means it's in that phase where it can easily collide. Are you able to get me or not? So that means, let's suppose if the mass is given to us, this is 2m. Okay, this is 2m and radius r, and this has velocity v naught. Okay, this one is mass m and radius r, and it is moving with it is at rest right now. V is equal to 0 for it. The gap between them, where their centers, is given to you, which is 2r by 3. How much? 2r by 3. Alright, if E is equal to 1 by 3, then find, if this is ball A, this is ball B, then find the velocity after collision. Velocity of ligno of A and B after collision. ठीक है? बताओ क्या होगा? ठीक है? You'll have to do this question. You try to do it, and then we'll discuss in the evening class too. Okay?